Okay, when you see this, points for the whole room. What should you be thinking? Kids, come on. When you see that, what should you think? This question I'm going to keep asking over and over again every day in class until everyone can raise their hand very quickly and be very precise in their answer. So what should you think, Jake?
We can find all the x and y coordinates in the interval.
So technically we could find all the x and y coordinates anywhere, but they're only asking us to look here. So we have an infinite list of xy pairs. We can find all of those xy pairs using this formula. So I'm going to do that. 0.2 for J. So how do we do that? Hands up, come on. How do we do that? How do you use this to find all the xy pairs? How? What's the method? Let's go, Devin.
Plugging in an x.
So if I happen to know x is 3, I can plug x into the formula. I can find the y value, which I don't happen to know the answer. This we could do on the way I can do. So I could say, well, if you plug in 0, the y value is going to be 12. So who knew that? 0.27. What if it's the other way around? What if you happen to know that you're interested in a y value that happens to be, I don't know, like 8? Now what do you do? Okay. Got it? Very good. We would put an 8 here, and so 8 will equal this, and then we have to use algebra or a calculator to determine the value of the x-coordinate. That's a much tougher task. How many knew it? 0.2 for now. Okay, so that's what that is. Okay, again, make sure you are concept focused, not problem focused. We're not learning how to do this problem. We're learning all the concepts that get used in the problem so we can use those concepts elsewhere. Okay, the idea of absolute max is really simple. You have a list, an infinite list of xy pairs. You would like to be able to look down this list and find which y is highest. That's it. Questions on what absolute max means? Now on the AP test, they will not always use the word absolute. They will often simply say find the max. Or they'll say find the greatest value. Something like that. The wording will change. You have to read what they say and figure out that what you're looking for is, which is the biggest y coordinate. Question? Okay, I personally don't know that you need a flashcard for that. Just to me, that's kind of common sense. But if it doesn't feel like common sense to you, I would definitely have a flashcard. On the test that will take place after the Thanksgiving break, that week after, it covers the entire first semester. So you can't really study for the test using a practice test alone. You have to make sure you have a really good set of flashcards reminding you of the concepts. So one thing you will be tested on is this idea, like find the greatest value. Cool. Okay. Turns out that finding the highest point, the method we are always going to use is this. We're going to compare, we're going to check, let's see, basically, hold on a second, I got to look at something I wrote down. My apologies for the delay. I don't want to say this differently. Where I wrote. Okay, so there are different names for what we're doing. The name I like best is, I'm going to call this the min-max theorem. This one you do need to have flashcarded. I'm going to call it the min-max theorem. There are other names I've heard, but nothing that seems too official. So min-max theorem says that f of x is greatest or least, so it's greatest at the start, the end of f, or where f prime of x is either equal to 0 or undefined. Now that you have to have memorized. F is going to be greatest either at the start of f, the end of f, or where f prime is going to be 0 or undefined. The reason for this, if you will understand the reason, it makes memorizing this a lot easier. The reason is f could look like this. In which case the highest point on f would be right here, the beginning of f. But f could also look like this. In which case the highest point on f would be this spot right here, where the slope of f is 0. F could also look like this, in which case the highest point on f is simply the end point, the final point on f. So that's where the theorem comes from. That the highest point or lowest of f is either going to be where f begins, where f ends, or it could be a place where f has a slope that is 0 or undefined. Because f could also look like this. That slope is not defined, but that would still be the highest point on f. There's no other place where f will be highest. It's one of those spots. Please.
How would you know which step to take? How would you know to either know the start or end, or would you go straight to getting f prime?
You actually don't know, so we go straight to getting f prime. Yeah, and then we do what some people refer to as a candidate's test. You don't have to know that name. But the idea is we identify what are the possible x coordinates where f could be highest, and then we literally have to test each point to find out which one is the highest. So there you go. Cool. Okay, so this does have to be memorized, flashcarded and memorized. And this is the reason for it. Question? Oh, please.
Will there ever be an instance where it goes like this, like when there are two?
So that could look like this as well. And I've never seen an AP problem where they would make the highest point occur in multiple places, but they could. But the highest point is going to be at the beginning, the end, or at some place where the slope of f is either 0 or undefined. 2 points. Okay. So can I erase this? Awesome. Okay. We need to learn a new tool. If we have a graph of f, it's really, really easy to see where f is highest. But they don't ever allow you to get points on the AP test by simply looking at a graph of f and just looking at the graph of f and saying, oh, that's not hard. The highest point on f is right here. Okay? They don't, yeah, darn. Yeah, they don't allow you to do that. They don't allow you to just look at the graph of f and say, yeah, that's, look, that's where f is highest. So what we do instead is we use a tool known as a sine pattern chart. Okay, so this is a new tool you've not used before. We don't have a calculator available to us. We could spend the time to try and relearn the tools you learned in previous classes for graphing something like this, but it's not worth it. A sine pattern chart's a much faster way to get a pretty good idea of what f looks like, or enough of an idea to help us solve the problem. So here's how a sine pattern chart works. First, you got to figure out what do we want a sine pattern chart of. I'm going to make a sine pattern chart of f prime because of Danica's charts, the relationship shown in Danica's chart. I'm trying to understand what's happening on f, but I'm going to study what happens on f by studying the signs of f prime. Signs meaning the positive and negatives of f prime. So I do need a derivative. So the derivative is going to be 3x squared minus 6x. Okay? Please memorize this. Well, no, that's not. Never mind. Okay, to make a sine pattern chart, we prefer to have whatever we're charting as factored as possible. So I'm going to factor this. Pull out a 3x, and that leaves x subtract 2. Okay, next thing, I'm going to draw a number line. Now, we're only interested in the interval that goes from x equal negative 2 to x equal 4. So we can start our number line at x equal negative 2. Stop our number line at x equal 4. Make sure the number line is pretty good sized. I've seen lots of mistakes occur because you make it too small. So this would be about 0. Here's negative 1. So that's not too bad. Just give enough space. Pause for a moment so you can make sure you have that in your notes. Please.
So I tried solving this on my own real quick before we did the sine thing, and I just did the derivative and got that and plugged in, got my answer of 2. So I plugged that into the original one.
Slow down. So you have the derivative.
Got the derivative, and then I solved for whether it equal to 0. Would that be incorrect? Would that be a very incorrect thing to do, or?
No, just keep watching so you get a little more detail.
Okay. Yeah, I did that, and then I plugged that in for, yeah, that's where I got all my zeros. I also plugged that original in, that's where I got 2. I plugged that into the original equation, back into that. And then I also plugged 4 in and negative 2 in due to whatever the min-max theorem is, to see what's the highest of those 3 values would be.
You're doing really well. Just keep watching. Yeah, don't discard anything you've done. Like I'm going to show you a couple other things that. Just keep watching for a minute. You're doing fine. 2 points. Okay. Next thing. He has sine pattern chart. I've seen them drawn different ways. This is the way that I like best. Sine pattern chart is a table. It's just drawn horizontally instead of vertically to make it look a little bit more like a graph. So this is the x-axis, okay, like a graph. But we're going to fill out a table, basically. So we take this factor, 3x, and we take this factor, x minus 2. Now caution, it doesn't work to make a sine pattern chart using terms. So you don't want to make a sine pattern chart of this and this. It will not work. You have to make a sine chart either using factors, or in some cases you'll have no choice but to just use this as like one large factor. Better to have smaller factors, it makes the chart easier, but sometimes you have no choice, you just have to use this as one large factor. So I list my two factors, I'm just building a table. And now all you're going to do is plug in different values of x and chart what happens. But all we care about are positives and negatives. So it makes charting a lot faster than when we make a table and we have to have actual numbers. You start with what Parker did. You start by identifying what value of x will make this 0. So that's easy, right here. So when x is 0, this will have a value of 0. Let's do the right color. Okay, so the way the chart is read, these are x values. I'm taking this value of 0 and I'm plugging it into this formula. 3 times 0 is 0. Here's the result. That's how you read the chart. Just wave if you need me to do that again. Cool. I go to this one. If x has a value of 2, I would take this value of 2, plug it in for x. 2 subtract 2 would be 0. So the chart is read like that. Okay. Next thing, now you test. The nice thing about the functions we work with is once we have identified the zeros where this factor has a value of 0, we can just test one of these x coordinates, and whatever the test result is for one x coordinate will be the same for all other x coordinates in that span. So I just pick the easiest x value I can see here, -1. I plug that x in over here. 3 times -1 is -3. So I don't care about the value being -3, I only care that the value is negative. So I put a negative sign to indicate that if this x were plugged into here, the result would be negative. That's all you have to worry about. Now you know that for the problems we're going to deal with, it wouldn't matter if I plugged in -2, the result would be negative. If I plugged in -1.5, the result would be negative. If I plugged in -5, the result would be negative. The result is always negative. You test once, you're done. Just wait if you need me to go through that again. So then over here, we just test as well. Warning, I've seen students in the past make an assumption that is not always true. They'll say, hey, these are negative, these must be positive. That is often the case, but is not always the case. So I just test. I pick an easy number, 1, plug it in for x. 3 times 1 would be a +3, so this is a positive number. I have no need to test the other x values. They will be the same sign. Parker, go ahead.
So yeah, but would that not fit into the one that's the x minus 2 factor though?
It's okay. On this table, this
This
row
is representing 3x.
only for 3x.
So then you're going to have 2 separate tables. I see.
You're doing great. 2 points for Parker. Other comments or questions? Oh, please, Maya.
So, whoa,
You're good.
So when you say when you're testing one of the numbers and it applies to all of the rest of those, do you mean it applies to all the rest of the numbers on either the left or right side of the 0, not
Correct.
just whether it's like positive or negative?
Correct. So the idea is you identify what value of x will cause this factor to equal 0. I make note of that. Then I know that because there are no other values of x which will cause this factor to be 0, whatever x I pick here and plug into this formula, if the result is positive or negative, it will be the same for any of the other x's in this span. Same is true over here. Whatever x value I pick, I can test it. The x values will have the same result in that span. 2 points. So we go here, we just test again. I think 0 is a really easy test. So we plug in x equals 0. 0 subtract 2 would be a negative number. So this is negative. Any other value of x that I were to pick and test, the result would still be negative. So you're building a table, but you're not caring about the numeric value. You only care about the positive or negative. Please.
I understand like, the whole idea of like plugging it in to find which one is 0, and then if it doesn't switch, then it's obviously going to be the same sign. But what does that x off to the far right mean? Like, it's kind of a random question.
Oh, the x over here is just indicating that what we have drawn here is an x-axis.
Okay.
These are simply values of x. 2 points.
That's really simple.
So this is just to remind you that these aren't random numbers, they're values of x. So like a graph, this is, like I want you to view this as though you are looking at a graph in a sense.
Yeah.
Okay, here's the most powerful part of the sine pattern chart. We basically are trying to get a picture of what f prime is doing. If you were to build a table of f prime, you would plug in an x here and here, you would find values and you would multiply. Okay, we are going to do the exact same thing, but we just do it in a different order. We find the values first. Let's test this one. So if I plug in a positive number, let's see. 3 subtract 2 would be positive 1, so I'm good there. Strong color. Come on. These are all positive. Okay, with the chart, what we do is we say, well, for all of these different x's, we now know how 3x behaves. For all these different x's, we now know how x minus 2 behaves. To find f prime, we need to multiply the result of these two factors. So the way you read the chart is, you say, okay, when x is negative 2, this portion of f prime will be a negative number. This portion of x prime will also be a negative number. Well, those two negative numbers would multiply. And a negative multiplied by negative becomes a positive. Okay, caution against the whole room. It's easy to copy what I do without understanding what I'm doing. Don't let yourself do that. It will get you into trouble when the problems become more complex. Question. You don't need me to repeat anything. So the same happens here. If x is negative 1, we were to put a negative 1 into this formula, we'd find out that this part of the formula has a negative result. This portion of the formula is also negative, but those two results have to multiply by each other. So negative times negative is positive again. This only works if the rows of the chart are factors. This will not work if the rows of the chart are terms. Okay? The best place to jump to is way over here. If x had a value of 0, well, this factor of f prime would have a value of 0. This factor of f prime would have a negative number. 0 times a negative would be 0. Here's why you don't want to have terms over here. If these are terms, then you've got to add the rows. But a positive number added to a negative number could be either one. So that's why you don't want to build a sine chart with terms. Now, the factors can be in the numerator or denominator because a positive divided by negative is a negative. A positive times a negative is a negative, so that doesn't matter. So I jump over here and I say, well, if x is equal to 2, the 3x factor would be positive. This factor would be 0. So multiplying, the result is 0 for f prime. Question? Cool. So in here, like when x is 1, this value is positive, this one's negative. Those two multiply, you get a negative result. back to positive over here. The question. You need me to repeat anything. Okay, the concept, oh, you're just thinking. The concept is very simple. It does get more challenging as you get formulas that are more complicated. But the fundamentals don't change. Okay? All right, now we have a sine chart of f prime. The reason we made a sine chart of f prime, let's copy this over. Let's see, page 4. Okay, so I'm going to erase this. Hold this up a little bit. Okay, the purpose for the sine chart of f prime is to now draw a sketch of what f would look like. Like I said, if you could remember everything you learned about how to make graphs, you wouldn't have to do this. But that other process of making the graph is much more complicated. The sine pattern chart's a quick shortcut. So, f prime from x equal -2 until I get to x equals 0, f prime is positive. So f is increasing. So this is my f prime chart. My f prime graph is going to look like this. So f prime is going to start by going up. This x-coordinate is known. That x-coordinate is -2. I don't happen to know the y-coordinate, but it could be found by plugging -2 into the formula for f. I know that when I get to x equals 0, the slope of f becomes 0. So this point is x equals 0, and the y-coordinate is f of 0. Now when f prime is negative, f goes down until I get to here. So this is an x-coordinate of 2. This spot here is x equal 2, and the y-coordinate is not known. And then from that point onward, f just goes back up. So this point over here, I don't know exactly what that y-coordinate is either. The x-coordinate is 4. Y-coordinate would be f of 4. Question. Okay. Looking at this, it confirms what we talked about regarding the min-max theorem. F has definitely this sort of appearance. So the lowest points on F would have to either be x equal -2 or x equal 2. The highest point on F would have to be either x equals 0 or x equal 4. The point of the sine pattern chart of f prime is to get a picture of f. That's the idea. Okay. Now, Parker was right. There are some problems where you don't necessarily need the picture, but there are many where you do. Like it just, the problem, how do I say, the problem, you don't have to have the picture, it just helps make sure you're understanding what's going on. So, questions or comments? The goal of the problem here is to find out which point on f is actually the highest. So we have to look and say, well, it's either this one or this one. We don't have to worry about these two. These would be points on f that could be lowest. So we just go find f of 0, and we go find f of 4. Question? Cool. Copy this one over. So erasing all of this. We just use the formula. F of 0 is going to equal 12. F of 4 would be 4 cubed minus 3 times 4 squared plus 12. So that's going to be 4 cubed is 64. This is 3 times 16 plus 12. 3 times 16 is 48. So that's 16 plus 12. I did something wrong. Oh, we're okay. So that's equal to 28. So the absolute maximum value of f is going to be 28, and that occurs at an x coordinate of 4. Questions or comments? Okay, cool. The other thing you get from this sketch is it does help you. Some problems will ask you to identify the relative max or the relative min of f. That sort of thing. Question? Cool. Okay, the blue and yellow packet. That's really the only new idea that shows up in these two packets. The rest are review ideas. Okay, this idea of absolute max or sine pattern chart, you'll want to use that tool to answer some of these questions here. Okay, let's do another example. So let's stop that one.